all of us hypochondriacs, we now have an even better reason to ask ChatGPT, or insert your favorite LLM model here, all the most embarrassing health questions. So pathetic. But the thing is, the latest research from Microsoft showed that an LLM in general is better than an average physician you might have at the diagnostic process, and an orchestrator system which uses a cohort of agents which communicate to each other is even better than that. There are some caveats, obviously, but let's look at the research behind Microsoft AI Diagnostic Orchestrator and what it says. So this is pretty fresh paper from Microsoft AI about sequential diagnosis with language models. And by sequential diagnosis, they mean actually that thinking process where physicians refine their diagnostic hypothesis step by step through iterative questioning and testing. And when physicians do that, they need this complementary set of skills. First of all, they need to understand what questions or tests they need to run next. Secondly, they need actually to take care of the costs they will have to pay and select those tests which make the most benefit for the price. And thirdly, they need to recognize when the evidence is sufficient to make a diagnosis with enough confidence. And large language models actually showed quite impressive capabilities when making a diagnosis. However, here in this paper they point out that there is not really much of evaluations of large language models in the real-world clinical practice. So often what was happening is that to a large language model, a story of a patient was given with a lot of different details, and then large language model could correctly identify what issue was with the health. However, this is not how stuff happens in real world, because when the patient usually is admitted, they have a bit of information about the health complaint, and then this investigation step-by-step process is needed to come into hypothesis and then validate and to give a confident diagnosis. So that's why the first thing they introduce is the sequential diagnosis benchmark. This is kind of a framework to evaluate how well both humans or AI agents can predict or can diagnose correctly the illness, or to kind of figure out what is happening with the health of that person. And they use as a basis, they use some cases from the New England Journal of Medicine, whatever it is, like some medical stuff. So they have those cases with the detail of the disease, but they don't really reveal everything to the humans or AI agents. They actually give it piece by piece by using a gatekeeper. We will look later how it works. But in any case, they actually compared how well physicians with a median of 12 years of experience can solve those cases comparing to AI agents. And physicians can achieve on average 20% accuracy, versus the models achieve almost 50% accuracy at a lower cost, while better models achieve even better than that. So they established a benchmark with which they can evaluate those agents, whether humans or AI. Then they introduced what they called Microsoft AI Diagnostic Orchestrator. This is where they combine the power of multiple agents talking to each other, having different roles. Again, we will see this in a second. And that improved the diagnostic accuracy and cut the costs. Actually, quite a big part of this paper is about the costs themselves, because in medicine, it's quite important to keep the cost lower and give better results with lower costs. But in any case, here they achieved 80% for the price of $2,300 or $400 per case, and 85% for a higher price. So, and this particular orchestrator here, it says, simulates a virtual panel of physicians with distinct roles. They describe the roles a bit below. So all in all, this diagnostic orchestrator could perform by an average of 11 percentage points better comparing than just normal off-the-shelf models. One more important thing to mention, this diagnostic orchestrator is not a new model, nothing new. It actually reuses the existing models and just builds the prompt and collaboration across the agents and the whole idea which agent will take which role. This is new, however, the whole models are the same models which we have access to. A bit more details on the benchmark, because this is such a big part of this paper. So they use 304 cases from 2017 to 2025. 2025 will be important later. And each of the cases had a brief summary of the patient and their chief complaint. And then a model was getting that information, initial information. You can kind of also imagine a patient was admitted to a hospital or came to visit a physician. And then an AI agent or a human physician, because both of them were using the same benchmark. So both of them could do one of the following steps. They could ask more questions. So a free text question for history or examination details. Has she traveled recently, and so on. So they could ask multiple questions. I didn't see if there is any limits to that. Then secondly, they can actually run tests. They need to order specific tests, not just like a general blood test, but they need to identify what kind of tests they are going to run, because that actually would also affect how much they will have to pay for the test, or submit a final diagnosis. Then they used here another agent to help with that. They called it a gatekeeper agent. This agent technically knew everything about the case. However, it was trying not to reveal too much to the diagnostic agent, so that diagnostic agent couldn't cheat on the system. For example, they tried first to respond not available when they didn't have that information from the patient file, for example, for some blood test or whatever. However, LLMs are smart, they try to cheat. If that particular test or result or information is not available, then it's probably not relevant to solve the use case. That's why the researchers changed the strategy of responding not available, and they just returned realistic synthetic findings for the queries not covered in the original text. And yes, the gatekeeper responses were also evaluated, just in case it was leaking some information or kind of misleading, or in the opposite way, giving a bit more information to the diagnostic agents than it should be. They looked into the responses and looked for any inappropriate ones. They found 8 responses as potentially problematic, but none of these found to leak the information. Then they also had a judge to evaluate if that diagnosis was correct or not. And the thing is, with any condition and medical stuff, it can be described in different words. So they needed some smart system which would look a bit deeper, knowing the original case, the file, which they had the true description of the disease or whatever was happening to the patient, and look to that and compare it to the diagnosis provided by the agent or physician. They also validated the judge. So among those 56 test cases, only in 5 of them, the judge and the in-house physicians disagreed. But there, actually, physicians considered that the judge was overly strict, and the judge was marking the correct diagnosis to be incorrect. So it's better than it would be vice versa. So at the start we saw that they took 304 health case challenges. However, they paid extra attention to the last 56 cases from the years 2024 to 2025. And they had a special interest to those because, in particular, those cases were happening or were published after the training cutoff dates for the language models. So those language models which were used for evaluation couldn't be trained on those 56 cases, which kind of makes sense, so that the model doesn't know deep inside what was happening. So they used 56 cases for this final evaluation. Now, talking about the orchestrator, which enhances the whole power of LLMs, they have 5 different agents which will debate among each other and then will decide together whether they want to ask a question, request another test, or to provide a diagnosis. And then, if they provide the diagnosis, it goes to the benchmark framework, or if not, it goes again to this chain of debate, and then they will be talking. During this process, also the cost will be analyzed, so that stuff. In this virtual panel, they had 5 specialized roles. They had doctor hypothesis, which was maintaining top 3 most likely conditions. Then they had doctor test chooser, which was selecting up to 3 diagnostic tests most relevant for those hypotheses. Then they had doctor challenger, who was playing a role of a devil's advocate, identifying some bias, highlighting some contradictory evidence, proposing some tests which would falsify the current leading diagnosis, and so on. Then there is a doctor's stewardship. Anyway, he was taking care of the costs and advocated for cheaper alternatives. Then there is a doctor checklist to perform the quality control and make sure that the whole thing stays consistent. For the whole flow, they evaluated 5 different variants. So they evaluated what if we will just ask for the instant answer solely on the initial information about the health complaint, without any questions, without any tests, nothing. Then, and that would be, of course, obviously the cheapest one, so you don't really run any tests. Then they allowed to ask questions, but no tests, just questions. The third one, budgeted. This is with a defined maximum budget to run tests and see doctors, all that stuff. And the panel could cancel tests when they saw the estimated costs. And if it was too high, they would cancel it. Then there is unconstrained budget. I like that. So this is a full panel with no explicit cost tracking. And finally, they simulated multiple doctor panels working in parallel with an addition panel to provide the final diagnosis. So instead of 5, they had multiple those groups of agents trying to predict what is the diagnosis. Now, similarly how to evaluate an AI, they evaluated physicians, and they use the exactly same system, it seems so, it just kind of in a chatbot interface. So then the physicians could interact with the chatbots. They didn't have any time limitations. However, again, if they would be ordering some tests, they would be paying for the test. If they need to ask extra questions, that means actually the person should visit a doctor. And that means that actually the person would incur some costs visiting a doctor. And all in all, and this is probably the most summarizing diagram from the paper, and on this diagram we put into one picture the cost of the diagnosis, the accuracy, and more or less the methods. So these crosses over here, this is physicians. And the big bold cross, this is kind of an overall accuracy plus cost for the diagnosis by the physician. Then we have our off-shelf models, and here you can find your favorite model to answer your questions about health. And also we have this blue line. This is the enhanced cohort of agents. This is where they compare all those different modes. What if we actually give an instant answer by those cohort of 5 agents? What if we allow only questions to be asked without any tests to be made? What if we allow 2K budget to make those extra tests, 4K budget, 8K unconstrained, and then multiple groups of those cohorts working together? The cost of running a model is such a tiny fraction out of the whole expenses here for running the health tests. That's why they ignored that. But in general, you can see that this cohort of agents outperforms significantly everything. And the physicians are not performing really well, even comparing to the LLMs without that enhanced collaboration. So here they say that they used O3 as the model for every configuration. However, they also run their cohort of agents across all different models, and this was this light blue is the boost which it was giving to the models, comparing to kind of their initial evaluation accuracy, or whatever, like how they scored on that by that benchmark. And again, they state that they do not update model weights. They only rely on prompting and orchestration for all this improvement. So this is super cool. And I mean, whether you're using ChatGPT for any medical questions or not, this is actually quite helpful, not only for the patients, but also to the doctors, I believe. Because often they don't have enough time to research every disease or every small issue, and this can be a pretty helpful hand to those, in my non-medical opinion. Totally not.